is, without having to do axis of symmetry substitution. It'd be really cool, right?
You can do it.
Well, there's a form. If it doesn't match the form, then yeah, you have to do axis of symmetry substitution. So, in general, here's your form. Y equals A times the quantity x minus h quantity squared plus k. So if it's in this type of a form, you know where the vertex is at just by looking at it. Okay? Your vertex is always hk. Okay? So a couple things. Your axis of symmetry. That means x equals h. Obviously, your vertex, remember, the axis of symmetry is always what your x value is. So if you have this form, and you know that h is your x value in the coordinate, then that's your axis of symmetry. Right, now, what makes this go to 0?
Y.
What's x have to be for this to go to 0?
H.
H. That's where this comes in. Okay? So if this goes to 0, this is all 0, leaving just y equal to k. So that's where I get the hk. Alright, I'll show you, we'll do some examples and it'll make a little more sense. Alright, so we already know if A is positive, it opens up. If A is negative, it opens down. The same thing applies here in this form. Alright, so example 1. And we'll just do 2 examples. Alright?
Oh.
That was good.
He actually did it.
It's someone that
I would hope it would be red.
Ah,
Alright, so it is in the HK
I'm a
form.
Mexican.
So first of all,
What are you talking
does it
about?
open up or down?
Down.
Down.
Wait, are we tracking these?
No. Where's my vertex? What do you think the vertex is?
I have no idea.
The
We all
vertex is
know
a
that.
coordinate. What's the coordinate of the vertex? What do you think? What makes this go to 0?
-2.
And then this stays exactly the way it is. So y is, when this goes to 0, all of that is 0, leaving -3. So notice that if it's in the parentheses, it's the opposite of what's up there. So it's going to be -2. If it's outside the parentheses, it's exactly what it looks like, -3. That's a little hint for future things in your math. If they're inside something, usually you're looking for the opposite. If they're outside of the grouping symbols, it's usually exactly the way it looks like. So you're going to have H and K in other forms in other math classes, okay? So just kind of keep that in the back of your mind. So my vertex is at -2, -3. And you said it opens down. Okay? Where do you think it's going to go through the y-axis? That's a tough one.
X-axis.
-7.
How'd you get it? You worked it through?
Plug 0 in.
This is going to be a trinomial, right? Which that's going to become a 4.
Yeah.
That'll make it a -4. -4, -3 is -7. So that's your C. So what she did was she expanded this into a trinomial, which the C in the trinomial is going to be 4. 2 squared is 4. But there's a negative out front, which is going to make that a -4. And then you got to add that -3 to it. So the C value in this, when it's expanded, is -7, which is what your y-intercept is. Okay? Any questions? Isn't that simple? Yeah.
So when you're looking for the y-axis, all you have to do is square the number, or square h, and then add or subtract.
Not h. This is not h. H is what you get to make this 0. It's written like this to help you understand that it's the opposite. Okay, yeah.
How'd you get -7?
If I expand this, I'm going to get x squared plus 4x plus 4. And there's a minus sign out in front. Okay? So that becomes a -4. Minus 3 is -7. The c, which is this position, the number by itself, is where it crosses the y-axis. But you got to make sure all the numbers are in there. Okay? Yes? Anybody lost so far? Let's do another example. Example 2. Write in Vertex form. So, given a trinomial, y equals x squared minus 4x plus 9. I want you to write it in Vertex form. What does this 2 mean? Yeah, but based on what we talked about this morning, special case formula. How would I make this into a special case formula? What did we do this morning?
Split it up into 2.
Factor?
What's it called? What is the lesson called? Completing the square. All right, so in this case,
Do they want to put a C on the other side and then put it back?
yeah. Okay, yeah.
3x minus 2 squared plus 9.
Well, again, what Luke was saying is we move c to the other side just for doing it. So minus 9, and then you have x squared minus 4x. Now complete the square. So 4 over 2 is 2. You're going to square that and add it to both sides, right?
Yeah.
Yes?
Yes.
Check. I'm checking for the people who are saying no,
Oh.
whether they understand it or not. All right, so this is y minus 5, and this is x minus 2, y squared.
Yes.
Anybody not get that?
Yeah, because it's minus 4x.
Minus here.
Oh,
so it's
yeah.
minus here. Now what? Y equals x minus 2 squared plus 5.
And now it's in
So what's your vertex?
2, 5.
Right.
I know. That's what Mr. Sean always says. Every time I'm like, yeah, you're right, because I know I am.
Awesome. Great story.
Okay, so here's what you're doing. Now these are two different things. One, you're putting one in vertex form. This one, you're just taking it out of, you're graphing it. Can you do this part?
I get that except for how you got the -7.
You would have, in reality, you have to actually multiply this out. X plus 2 times x plus 2. That's x squared. That's 2x. That's 2x, gives me the 4x. And 2 times 2 is 4. So I went ahead and multiplied that out, but I have a minus sign in front. So the minus sign makes this negative x squared minus 4x minus 4. Okay? But then I also have a minus 3 there. So what's C? Minus 7. C is where it crosses the
So
y-axis.
can we just distribute the 2 onto the other 2?
No, you can't do that. This 2?
Yeah.
No, that's not what that means.
No, I mean, because I can figure it out just by squaring the 2.
That's not distributed.
My bad.
Okay, yeah, that's fine.
Okay.
But don't forget what's out front. Okay, on this one you have to complete the square, like you did this morning, to make it into this special case form. Once you do that, and then you put the C back over to the other side, then you have HK, which is it's the opposite of this, positive 2, 5. Okay? Alright, so there's only your assignment, it's a short assignment. Page 670, 1 to 13 all.